My name is Denise, I'm 27 years old and I came from Italy. I studied mathematical engineering and I'm now here in Halle for my PhD. I always liked mathematics and my biggest fascination is that we can describe everything, all what we see with numbers and equations. My research is mostly about improving existing numerical methods. What that means is, whenever we have an object that moves in real life, we can describe the movement with an equation or many equations. And to solve these equations is usually not so easy to do it by hand, and we need computers and programs to solve them. And what I do is actually using existing programs that solves already the equation and improve them and make such that it's faster. We get a solution of the equation faster. Because in industry, we don't have much time. We don't want to spend a week to solve the equation. We would like to do it maybe in a day, maybe less than a day. So my research can be applied to many subjects in industry, but the focus in our project is about cables. For example, we assemble a car. We want to study how the cables are moving, or when we open the door of the car, how all the electrical cables are moving inside the car, and if they are stretched, what kind of forces act on them, and how long will they last, for example. What we want is to have an exact prediction of the future. We cannot have it for real, but if the solution is correct, then it means that we sort of have a good prediction of what will happen.
I'm Ergus, I'm 27 years old. I come from Albania. I have completed my bachelor and master studies at the University of Camerino in Italy in mathematics and applications. Currently, I'm pursuing my PhD at the Norwegian University of Science and Technology in Trondheim in Norway. And I'm here in Halle for 1 month period to join the team of Denise and Martin. Thread for me is a teamwork, so each of us is supposed to give his contribution in this project. Like, I believe we are here to construct a puzzle, and each of us has its own contribution. And what I specifically do in Thread is a bit more abstract than what the other members do. I'm more focused on numerical methods for mechanical systems which evolve in Lie groups and manifolds. The main idea behind is that we consider these applications of Thread in mechanical engineering, automotive engineering and aerospace, offshore, different applications in industry. We are trying to simulate, to build methods which allow these industries to test their systems before they do really physical. Like, we test them numerically, because if they would test everything physical, that would be very expensive for them. In my case, we test methods. So, for example, now we are a bit shifting our focus to what is called contractivity and Riemannian manifolds, and we are considering for now the case of a sphere as a toy example, where we want to measure the distance of 2 points in the sphere in a round ball, and see that how the distance between these 2 points evolves in time. I do not expect or hope to make any big change in the world, but I believe that in a teamwork, everybody gives his contribute toward these challenges that we are facing in industry. And I believe that at the end of the project, some of them will be solved.
Working with the team of Professor Arnold is really interesting, and it's insightful because we have also weekly meeting where we share ideas, we present our work, and it's a great opportunity to see the subject from another point of view, and people will for sure make a very interesting question that you didn't thought before about it.
The European Training Network THREAD is a joint project of mathematicians, applied mathematicians and people from mechanical engineering. And we try to develop new and improved methods for computer simulation of highly flexible slender structures, as we call it. That means beams, ropes, cables, and so on. THREAD is a European training network. That means it's a graduate school with at all 14 PhD students at 12 universities in 8 different European countries. And furthermore, each PhD student is working on their individual topics, on their individual research projects at their different places. From the mathematical and engineering viewpoint, the project is structured in 3 so-called research work packages. The first one considers the physical modeling and physical experiments that are performed by our colleagues at the Fraunhofer-Institute in Kaiserslautern and at different places in the network to get more knowledge about the physical background. The second one is coordinated by the colleagues in Innsbruck. They consider contact modeling, like in ropeway systems and so on. And the third one has some focus on mathematics, on applied mathematics, on numerical methods.
I said, why don't we go to Innsbruck? But Innsbruck is far, I guess. I've never been there. I would love to, but...
I think it's not too far from here. I mean, the other colleagues from THREAD, they are, first of all, I admire them. We do not only work together, but we do what friends do. We go out together, we visit cities together where we didn't live. We have a great relationship.
We came back late. We just let Denise know so she could tell the other people.
I am Konstantina and I am from Greece. I studied mechanical engineering in Volos in the University of Thessaly. I live in Austria and I am doing my PhD in the University of Innsbruck. Right now I am here for 1 month in Halle, collaborating with a local group. So my research focuses on highly flexible structures, and the application is on ropeway systems. So we are thinking of the rope as one-dimensional highly flexible beams, and the discrete masses is an idealization for the cabins. Yeah, so for example, a first test case that we wanted to run in order to simplify the system was just an axially moving beams, and we also considered the discrete masses. So the experiment was to increase the number of masses and observe the behavior of the system. And we saw that for a very increased number of masses, the system converges to the continuous case as if we had only one beam with continuous mass. I had also the opportunity to work in Leitner, and I have visited sites of ropeway systems. Also, my colleagues explained me a lot of details about the design of ropeway system and the details about the construction and the calculation of the line.
It's a very important part of these innovative training networks, as they are called, that we have close contact to industry. All our PhD students go for 3 month of a secondment to one of the industrial partners, and these are 14 more partners in the project. They do not have PhD students, they just host our PhD students for such a secondments, and these are leading European companies, some spin-off companies also from Fraunhofer Institute and from several universities. But we have also larger industrial companies in the network as partners of THREAD.
I think that when THREAD finishes, we will realize how much it has given to us. Now we're doing the PhD. We are not aware of how much we have taken from THREAD, all the skills and the trainings beside the scientific part. But when it ends, we'll be very rich, let's say, in our mind and personality and knowledge, I guess.